All right, good morning, Math 3 students. This video is going to go over exercises 31 and 32 from Big Ideas 8.2. Okay, so 31 says, a CD player reads information from the outer edge of a CD. The CD spins 200 revolutions per minute. At that speed, through what angle does the point on a CD spin in 1 minute? Now, the answers are right there, 72,000 degrees or 400 pi. Okay, let's find out how they got that. So first, with all these problems, we need to figure out what category are we in, what type of solving are we doing. And if essentially we're doing a conversion problem, this is no different than if they give you a velocity, you run at 13 feet per second. Remember, our problem is revolutions per second. This is 13 feet per second. How far do you run in 1 minute? So feet per second or revolutions per second or dollars per hour, something per something, does not matter. If it's per, it's a rate, and here's how we're going to do it. So first, we write 13 feet per second. 13 on the top, seconds on the bottom, feet per second goes like that. It's a ratio, a fraction. Now, we're going to multiply that times 60 seconds per 1 minute. Why did I set it up like this? Seconds has to cancel with seconds. We don't want seconds anymore. We want to get into minutes. So I had to have 60 on top and 1 minute on the bottom, because if I put seconds on the bottom, it wouldn't cancel. All right. Once you got that, now you just need to multiply. So multiply across the top, you get 780. Across the bottom, 1 times 1 is still 1. What are our units, though? Feet was on top. Minutes were on bottom. That's 780 feet per minute. Okay. 780 feet per minute. All right. So our problem is essentially the same. So our problem has 200 revolutions per minute. Okay. And we're going to multiply by some conversion factor, and they wanted our answer in degrees per minute. Okay, so the reason I write it out like this is now I know where I need to get to. I need to get to degrees. Minutes is not going to change. We're still doing minutes. So if I need degrees on top, I need to have degrees on top, and I should no longer have revolutions. Okay, now what's degrees and revolutions? Well, 1 revolution of a CD would go all the way around, which would be 360 degrees. 360 degrees is 1 revolution. We set it up like that, and now it's just multiplying across. Revolutions cancel, and now you just have 72,000 on top and 1 on bottom. So that's 72,000 degrees per minute. 72,000 degrees per 1 minute. Again, when you see per, it means a fraction. Now, if we're doing radians, it's the same thing. 1 revolution is 2 pi radians per 1 revolution. And again, the way I know it has to be this, do I multiply by 2 pi or divide by 2 pi? It has to be on top. 2 pi has to be on top because that's the only way revolutions would cancel. And now you get 400 pi. And you start to see how pi is a little bit nicer to work with. You don't get 72,000. Okay. What is this, though? Again, that's radians per minute. Because radians was on top, minutes was on the bottom. Okay. And there you go. And this works for any type of conversion. Now let's take a look at number 32. You work every Saturday from 9 a.m. to 5 p.m. Find the measure of the angle generated by the hour hand clock during this time in both degrees and radians. And then compare it to the minute hand. Okay, we'll do hours and minutes. All right, so this is a little trickier, but it's not too bad. 9 to 5 is 8 hours. Or if you're looking at the clock, I'm very visual, I like to look at it. You're going from here down to here. Okay. So what is each individual marking on this? Well, it turns out we've already done this. Okay, we've already done this with the unit circle. That's a badly drawn unit circle, but okay. 30, 60, 90, 120, 150, 180, that's a 50, okay, and so on and so on and so on. If you went by 30s, there are 12 30s to get to 360. This ends up being exactly the same as the hour hands on the clock, except for this is that would be 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, da 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 da. It's the same amount of distance between each two numbers. There's 30 degrees in between them. Okay? So this is essentially a conversion problem as well. You got 8 hours times 30 degrees is how far the clock moves in 1 hour. For every hour, it goes 30 degrees. All right. Oops, sorry. Now you can see it. 240 degrees, or I guess I could just put the little degree sign up top. What happened to the hours? Hours canceled, and you just have your answer in degrees. Okay. If that's still a little bit tricky for you, think from 9 to 10 it went 30 degrees, then 30 degrees, then another 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees. And together all those 30s would give you 240. Okay. Now since we already have the answer, we can go 240 degrees. Or I'm going to write the word degrees. So to convert that to radians, and if you get confused, is it pi over 180 or 180 over pi? I get confused too. How do I know it's pi on top and 180 on the bottom? Because that's radians and 180 is degrees. And I knew I had to cancel degrees. So when we multiply this, we'll get 240 pi over 180. But degrees will cancel. And again, so that will now be in radians. The next thing you want to do is convert 240 over 180, ends up being 4/3. Don't forget the pi. Almost always radians will have pi. Not always, but most of the time, if you have pi, you're probably in radians. Okay, most of the time in this book, most of the time in this chapter. All right. So now you got that. That's 4 pi radians. Sorry, 4 pi over 3 radians. Okay. Now, for the minute hand, we got to think about this a little bit differently. The minute hand starts at 12 o'clock, right? And the hour hand was on 9 o'clock. There's the hours. We'll put minutes in green. The minutes will be in a green line here. After 1 hour, the minute hand goes a full 360. Rotates 360 degrees per hour. Degrees. So minute hand rotates 360 in 1 hour. But we said at the beginning you're working 9 to 5, you're working 8 hours, so times that by 8 hour shift, and now there's going to be your answer. Okay, so that's 2,880 degrees. I'll put degrees up here because I wrote that kind of ugly. Degrees. Looks like dog. All right, anyways, ignore that. I'll push it off the page. 2880 degrees. Again, every hour the minute hand goes around once. So it'll go around once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. And that will be 2880 degrees. So that'd be like 360 the first hour, 360 the next hour, 360 the next hour, 360 the next hour. Add them all up and you should get that much. All right, so hopefully that helps. Send me emails if you guys have questions, you guys, and we'll talk about it more in class. Thanks for watching.